Hi, I'm Tim Herman from 3D Molecular Designs, and I'd like to invite you to join us this summer in our flagship course, Modeling the Molecular World. So I'd like to talk just for a few minutes about that summer course. This is something we've been doing for about 20 years now. So it's a fairly well-developed course at this point, and we introduce basic principles of chemistry, and then we apply those principles of chemistry to the 20 amino acids that make up proteins. We fold proteins following those basic principles. We talk about enzymes. We talk about active sites. One thing I forgot along the way, we talk about membranes. We start with water. We have membranes that separates the outside of a cell from the inside. So therefore we have a need for proteins, transmembrane proteins that transport water, as well as ions and other nutrients in and out of cells. So a large part of the course is focused on proteins. We're very protein-centric, but the last half of the course is based on DNA and how a sequence of nucleotides in DNA encodes that sequence of amino acids in a protein, which folds up into these amazing molecular machines. And why should you come to Milwaukee and spend these 5 days with us? I think the best reason is because you should think of it as an investment in yourself. One of the most common pieces of feedback we get from teachers is that this course has changed the teaching, changed the careers of many, many teachers. And that includes brand new teachers who are just learning how to handle a classroom and engage students in topics, as well as veteran teachers who are probably really good teachers when they come to us, but they've also been teaching long enough to know that they're not really engaging their students at a depth that they would like to. So they're looking for something more. And to us, that something more is the use of physical models. We often like to say that models give meaning to words. So you can speak very clearly, very slowly, very precisely to your students, and you can explain some molecular process to them. But they're just words. And when you then put in the hands of students a physical model of whatever it is you're talking about, suddenly your words have meaning. So I encourage you to come to the course. I especially encourage you to come to the course with a colleague, another teacher from your school, or even someone you know from across the country. We find that when pairs of teachers come and have this shared experience of a summer course, and then when you go home and start using these materials in your classroom, it's always nice to have someone with whom you can compare notes and plan as to how you're going to do that implementation. So we look forward to seeing you this summer.